Welcome to CS 270. Today we're going to take a look at Lab 3. This lab is due in a couple of days, but I haven't seen a lot of submissions for it, so I wanted to walk you through it, show how I do at least part of it. So in this assignment, you're going to be calling an external program. That is doing fork to make a new process, and exec to have that new process replaced with some external program. But we're going to do one more thing as well. We're going to redirect. What do I mean by redirection? Well, so I can run a program on my virtual machine like ls, or maybe I can ls in my home directory, so we can see a few more things. In Unix, I can also, with any command that I run from the command line, redirect its output using the greater than sign. And then I give a file name after that. And notice it didn't produce anything to the screen. But if I cat the file, I can see the file names are there. Maybe I shouldn't have used ls as my example because it's a little bit weird in that if it sees its output is going to a regular file as opposed to a terminal, as opposed to the screen or your SSH session or so on, it formats the output a little bit differently. It doesn't try to do colors, and it puts each file on its own line. But nonetheless, we can see that all the things that it would have printed, instead of going to the terminal, they go to this file. We can also redirect programs from standard input or redirect standard input in a process if I want to have a program that normally reads from the keyboard read from something else. So in this assignment, we're going to be executing an external process, but redirecting its standard output so that it goes to a file instead of where it usually goes. So let's take a look at what we need to do. Now, in this assignment, we can use either C or C++. Normally, I would use C for this kind of thing, but there are a few gotchas in this assignment regarding C++, so I'm going to do it in C++ so we can see how to solve those. So, scrolling down to the steps of the assignment, we want to create a function with this particular prototype. All right, let's copy that, go over to the assignment. I'm going to need to make a file. I'll call it redir.c for redirection. Here's my function prototype. And I can go ahead and put the body of the function here. Of course, I'm going to have to fill in quite a bit. But if we look carefully, we see that if we're using C++, the type will be slightly different. See note 2 at the top of the assignment. Well, note 2 at the top of the assignment says if you're using C++ rather than C, you're likely to get warnings about converting string constants, those are things you double quote, to char star, because in C++, they're const char star. You're not allowed to modify their contents. So we'll need to add const qualifier to the function arguments and to the types of my arguments array. And there's one more thing I'll need when we get to doing exec_ve. So all my char stars, I want to make const char stars, and that way I can call them with just a double quoted string. Okay, so let's take a look. That was step 1. And just to be clear on what we're doing, this function runs a program that we give it. It gives it a list of arguments, and it redirects its output to a particular file. It waits for the child process to finish. That's the reaping we talked about in the last video. Also, if any of the system calls we make report an error, we'll print an error message and return false. Otherwise, if there were no errors, we'll return true to indicate that everything was successful. Alright, so for every library function and system call, we're going to need to include the appropriate headers. Well, so we haven't used any system calls yet. We'll get to that soon. To begin, call fork, assign its result into a variable of type PIDT. Fork takes no arguments. It returns a PIDT. And then with any fork, we're going to write a conditional to handle the different cases. With fork, that could be the parent process, the child process, or it could be that there was an error. The process wasn't able to fork. That's not necessarily a common error, but if the system's very overloaded and there isn't any more room in the process table, or if you're on a system that has quotas, limits on how much of different kinds of resources each user can use, in cases like that, you could get a failure of fork. So in order to call this, I know I'm going to need a PIDT, and we'll call it PID because remember in the parent process, it's going to be the process ID of the child. In the child process, it'll just be 0, and if it's negative, that means we have an error. Now, I've got to do something now. I have to include the appropriate header file. So, going to the command line with Control-Z, I can man fork, give it a minute to load, and I see I need to include sys/types.h and unistd, Unix standard functions. So I will just copy these. That was FG, by the way, to get back into Vim after I used Control-Z to suspend it. Okay, so now I have the headers I need for fork, and I can say if PID, we have 3 cases here. So if PID is less than 0, we do one thing, else if PID, so now I could do either the parent or the child process. Since the parent's mostly going to be waiting on the child process, I think it will be a little bit simpler to put the child before the parent, or it's equivalently simple either way, but it might be a little more readable to do that, but either would work. All right, so now I have my if with my 3 cases. So if the variable is negative, there was an error, I need to use p_error and then return 0 from the function. So we're not exiting the program altogether, just this function. So p_error. So with p_error, remember the cause of the error, for example, out of resources or bad file descriptor or insufficient permissions, is appended automatically to the message we give. So the message we give should indicate what we did that caused the error, the context of the error. So here, fork failed, or maybe could not create a child process, and will return 0. Now I need to be careful here because could not p_error is itself a library function. I need to include the correct header. Fortunately, it's standard I/O. Well, I say fortunately, but actually, since I'm writing in C++, I wouldn't be using stdio that much otherwise. So I definitely do need to include it. All right, so now, if the variable is 0, this is the child process. That's going to be steps 4 and 5. If the variable is positive, it's a parent process. That's going to be step 6. So let's go on to step 4. In the if branch for the child process, first we need to set up an output redirection. To redirect to a file, we need to do a couple of things. We need to open the file, and we're going to use not the C++ file I/O facilities, but rather the lowest level Unix file I/O system calls. So that will be open. Open takes several parameters, so we need to take a look at that. But we need to pass our file name, of course, the flags we want to use, which I'm going to go ahead and copy, and a particular mode for the file to indicate what permissions the file will get. So let's check man open. Okay, so we got a manual page for a completely different program, OpenVT, which is in section 1 for programs. So if I want to look at the manual page for the system call, I need to explicitly say man2 open. All right, and here we go. And I have a few headers: systypes, syststat, and fcntl. We already have systypes, syststat, and fcntl. And it's probably a good idea to indicate which library functions or system calls we're using or we are including each header for. That way, if I change my program later to do something else, I can easily look and see which of these headers I can remove. Okay, so now I need to call open. So open, manual page 2, open takes either a path name, that's a file name, but it could include slashes as directory separators, takes a set of flags, and then optionally it takes a mode. I'm not going to read through the entire man page, but this mode isn't actually optional. If I'm opening a file in such a way that it will cause a file to be created, I need to include the mode. If I'm not going to be creating a file, if I'm just opening something for reading, then I don't need to include it. So let me come and copy this because it's been replaced on my clipboard. So I need to open my out file with these flags. That is to say, I'm opening the file for writing only, create the file if it doesn't exist, and if it does exist, truncate it to 0 bytes first. So rather than appending to an existing file, this will overwrite one, which is exactly what the greater than sign does on the Unix command line. There's a separate redirection with 2 greater than signs to append to a file. And then I give the mode 0666. These are Unix file permission modes. So this stands for read and write. Read is 4, write is 2, execute would be 1. For the owner of the file, for the group that owns the file, and for everybody else. Now, the file isn't actually going to be created with these permissions because there's something called the umask, which is kind of a global variable in a program that is ANDed with the permissions of all files we create. And our umask is this. So write permissions for everybody else will be stripped off anyway. Okay, now you may have noticed a problem here, which is I'm not doing anything with the output of open. Well, I am going to need to save that. It returns a file descriptor, which is just an integer, so I'll make a variable for that. Now, open can return an error. So let's check the manual page and see what the return value means. Return the new file descriptor or -1 if an error occurred, in which case error no is set appropriately. So if FD is less than 0, it said -1, but checking if something is less than 0 is actually a little bit easier if you remember the comparison routines we've seen in assembly language. This turns out to be maybe 1 instruction less or a shorter instruction at least. So if the file descriptor is less than 0, then we will p-error could not open file for redirection. And, well, what do we want to do here? We may be tempted to return, but remember, we're in the child process. The parent process is also going to be running, do whatever it needs to do and return back to main. If I return inside the child process, then it will also go into main, or whoever called call redirected, and I'll have two separate processes running the same thing. So we want to instead use exit. And with exit, 0 indicates success, non-zero, so we'll use 1 here, indicates failure. Now we should probably check the manual page for exit. It uses stdlib.h. Okay, so now we've opened the file. Let's see what we need to do next. Otherwise, we use the dupe2 system call to move the file descriptor that we got to descriptor 1, and if dupe returns a negative number, that indicates a failure. So dupe2 is a system call. There's also dupe and dupe3, but dupe2 is probably the most commonly used of them. Dupe2 takes a file descriptor number and another file descriptor number, and it makes the whatever file is open on the old file descriptor, the new file descriptor will refer to that same file. Actually, it will refer to the same open file structure in the kernel, meaning that if I read from one of these or write to one of these and then write to the other one, the file pointer will advance in comma between them. They are really referring to not just the same file on the file system, but the same open file. We just have two numbers to refer to them. So the new file descriptor here, that's where I'm going to give standard output. So I want to take this file I just opened, which is on some file descriptor, the one I saved in a variable, and make it appear also on the new file descriptor. Okay. And standard output is file descriptor 1. So if dupe2 returns a negative number, that's an error. So here I don't need to save the result of dupe2 other than to check if there was an error. So dupe2 takes the old file descriptor, that's the one that I got from open, and the new file descriptor, which will be standard output. Now here I have a bare constant in my program, and it's not just any non-zero number. The number 1 is specific, so maybe I will make a constant. That's not necessary for this assignment, but might make the code a little more readable. And if that returns a value less than 0, then again we're going to print an error. Could not duplicate file descriptor. Or if you wanted to just say dupe2 failed, that's fine as well. Then we'll exit. All right, so now we are in the child branch. After we get past that if, we know dupe2 succeeded, so we have our file on standard output. So we need to call execve. Execve takes a file name, a list of arguments, and an environment. So we're going to have to take a look at those things. And execve, I need to include unistd, which I've already included, so that's great. It takes a file name. This is the file I'm going to open, const char star. Okay. A char star const of the arguments. This isn't exactly what we have. So this is an array of constant pointers to non-constant characters. So argv is an array containing pointers. I can't change those pointers, but I can change what they point to. Now in my function's arguments, I did not write it that way. I made it a const char star. So that is an array of modifiable pointers to constant strings. So I can modify the pointers in my argument. I can't modify the string itself. That means in C++ at least, I'm going to have to do a cast. If I were writing this in C, I would have just said char star args and ignored the constants, and it would have been a little bit easier. So exec VE, I need to give the program, I need to give the arguments, but since I'm doing this in C++, which is much pickier about constants, I need to cast them to char star const args. Char star const star args. Well, args is an array, but remember when we pass an array into a function, it's really being passed as a pointer to the array. And if I use the name of an array in an expression, it turns into a pointer to the array, which is why this is char star const star. This extra star is because args is going to be converted into a pointer to an array, and then I'm going to cast that to the appropriate constants, not that the strings being pointed to are constant, but that the array itself is constant. And then I need to give the environment. We're not going to do much with the environment right now. I'm just going to pass it in as it was. I need to use extern char star star environ. This is a global variable that points to our environment. It's an array. It's terminated by a null pointer. So this is a pointer to an array of pointers. Each pointer in that array either points to a string, or if it's the last one, it's null. The variable must be declared in the user program, but is declared in the header file unistd if the GNU source feature test macro is defined. So that's going to depend on how I call G++. If I tell it to use a particular standard like C++ 11, this isn't going to be defined. But if I compile it with the default flags, then it will define this. That's equivalent to something like standard equals GNU++ 11 or GNU++ 98, which turns this on. This says I want things that are specific to GNU, which is the most of the user space on Linux. Our libc, for example, is GNU. GCC is the GNU C compiler, and so on. All right, so let's go ahead and include this. Also, let's update unistandard to indicate that, or update our include comment to indicate that unistandard is also being used for exec VE. And then I can pass in environ to exec VE. All right, notice I'm not looking at the return value, because if exec VE was successful, it doesn't return. Meaning, if I get to this line, the line after the exec VE call, I know there was an error. So I can p-error could not execute process, and again, exit. Now, if I wanted to, I could have all of these exits in the child process use different numbers to indicate the different kinds of, or the different reasons they might have failed. In fact, let me go ahead and do that. Not all programs do that. Many of them will just use 1 to indicate that something failed, or maybe they'll, in a program like grep, for example, that searches for things in a file, it might return 1 to indicate that it wasn't found, and 2 or a larger number to indicate that there was an error of some kind. All right, and this is our child process. We're opening a file, using dupe2 to put that file on standard output, and we're executing the program. And if any of those steps failed, we print an error message and exit the child process. Okay, so that is step 4 and 5. Now we're ready for the parent branch. So when the PID is positive, we need to call wait to wait for the child process to end. We could use wait PID as well. We do have the PID and we only have one child process. But in this case, wait's a little simpler. We don't have multiple child processes, so we don't have to wait for a specific one. If we wait for the next child process to terminate, it must be this one that we just created. Wait returns a PID, or -1 if there was an error. It also takes as an argument a pointer to an integer. So we're going to need that integer variable that will hold our exit status, and a process ID variable to hold the result of wait. We call wait, we pass pointer to the integer. If it returned a negative number, we call p-error. Otherwise, we use a couple of flags. Actually, although the assignment says I need a PIDT variable to hold the process ID, all I'm going to use that for is to check whether it's negative. If it's negative, there was an error. If not, it wasn't an error. Okay, so check the manual page for wait. I need sys types and sys wait. I already have sys types. And now let me scroll down to the parent process. So int status equals 0. This is going to be the exit status, or the variable that holds exit status from wait. If wait ampersand status is less than 0. Now we're in the parent process. We'll say we could not wait for child, and we'll return 0. We don't want to exit the whole program. We want to go back to our caller. We had to use exit in the child process so we don't end up with duplicate processes both returning to the caller. That could get confusing, and if this were part of a larger program, could mean we now have two programs running and doing the same thing, or two processes rather. All right, so that's calling wait. Now we need to do something with the exit status. So in the manual page for wait, it describes some macros. I mentioned those in the video on reaping child processes. We want to use those to check the exit status, determine whether it exited successfully. If it did exit successfully, we'll return true. If not, we'll return false. So if I could use an if actually, but return if exited status and exit status equals 0. So I could have written this with an if. If it exited and the exit status was 0, return true. Otherwise, return false. But I can do that by just returning this expression. This expression will be either true if both of these were true, or false if one of them was false. And that is our function. There's still a little bit more to do. We need to write a main to test our function. But before I do that, let's make sure I can compile. So I'm going to G++-C. I can't compile this to an executable. I can't do the linking step because I don't have main. So I'll just ask it to make a object file. And I already know I'm going to have a problem. Have you spotted it yet? Well, actually I didn't have a problem. By pure luck, everything that I've written here is actually valid C, even though I intended to do C++. Now, back in main, I probably am going to do a little bit of C++. Well, I use G++, so what's the problem? Well, I named my file readir.c, and G++ will compile the program as C if that's what the, or compile the file as C if that's what the extension says. So I exited them, so I can come to the command line, rename this to readir.cc. CPP works as well. Now let's test this again, actually compiling it as C++. And still no errors. Still no errors if I turn on all the warnings, and if I turn on standard mode, still no errors. All right, great. And might as well do one more. Pedantic is a flag you can give to GCC or G++ to tell it that even when it knows what you meant, if what you said doesn't follow the standard, don't allow it. And that still worked. Okay, so let me go back to my program. Now I need to write a main. I'm writing in C++, so I can just put list the arguments as an empty set of parentheses. If this were C, I would need to write void in here between the parentheses to indicate there are no arguments. I want to create an array of character pointers that will be my arguments. So I'm going to call the program ls with the command line arguments -l/, and then the null pointer as the terminator. So ls-l/ lists all the files in my virtual machine's root directory. So const char star args equals. Now, if I were writing this in C, I could get by without the const, but in C++, I really do need it. And it's actually an array of pointers. ls-l/null. And in C++, if I'm using C++ 11 anyway, I can use this null pointer constant instead, or null pointer, which is a little bit nicer than the null macro. There are a few cases where using the null, not this case, but a few other cases where using the null macro, capital NULL, could result in strange things happening because it actually expands to just 0. Because in C++, if I did make it return an actual pointer, or if I did make it evaluate to an actual pointer, I would have to do casting of that pointer from one type to another. Here, null pointer is of its own type, and it can be automatically cast or implicitly cast to any pointer type. All right, so there are my arguments. So this 0th argument here is the name of the program I'm calling. But this is not actually going to be used to determine what to execute. This is simply what we're telling the process its name is going to be. If you've written programs that use command line arguments, int argc, char star argv, or something like that, then you remember that the 0th argument in argv is actually the name of the program, and that comes from the argument we pass here. I could make this anything, and it wouldn't affect the results for ls. There are other programs that look at their argv0 and decide to do different things depending on what name they were called with. That lets you make one executable that can handle a lot of different tasks, and you specify which task it is by how you call it. And then you can make symbolic links or so on to that executable so that the name it gets called by can be different without having to explicitly use execve here. Okay, so those are my arguments. I'll also want to pass as my program the file that has the executable for ls. Execve does not search the path. It doesn't look to see where ls is. If I tell it ls is my program, it will simply tell me, no, there is nothing here called ls. So I need to know where ls is. The assignment tells me, but the way you can find that out is with which. Which, you give it the name of the program, it will search the path for that program and return the first thing it found. What's this path, by the way? These are the directories, separated by colons, that that things like exec vpe, so that's exec ve, but it searches the path, where things like that look for programs. They will first look for user local sbin ls, then user local bin ls, user sbin ls, user bin ls, sbin ls, bin ls, user games ls, and the first one that it finds, that will be the answer. And that's exactly what which did here, and that gives me bin ls. I'm not going to do the path search in my program. I am just going to call it as it is. And anything else I should do? I probably want to check the return type of, or the return value of my function call as well to indicate whether the program successfully executed. My output is going to be ls-out.txt. So coming back up here, I need to call redirected, my program, my arguments, my output file. If call redirected bin ls. So this is a string constant, which is a const char star. I'm not allowed to actually go into the string and modify it. I can't change this b to something else once I've created the string, which is why I had to change call directed to take a const char star as its argument. The same thing here. These things are constant, so it really needs to be const char star args square bracket. I can pass my args, and I can pass my output file, which I will just call name explicitly here. And if it succeeded, I'll print an error message. I could have used indel here instead of explicitly putting a new line in my string, but there is a difference. Indel, besides moving to the next line, also flushes the output, so it makes sure the output isn't buffered, that it's actually been written to wherever, in this case, the screen. For an interactive program like this that's running with the terminal as its output, doesn't make much of a difference because the terminal automatically flushes at each new line. But if I were writing the output of this program, not of ls, but of my redir program itself, if I were redirecting that or so on, it could make a difference if I had many more things. Indel is typically a little bit slower than writing just a new line, sometimes more than a little bit. So by indel, I mean this thing. All right. Now, in main, I really should return something. So actually, let me do this. I can even have my program return a exit status indicating whether the call succeeded. Now, remember, call redirected is a function. It's returning, like most functions that return a Boolean. It's an int here, but really that's just the C way of saying Boolean. Like most functions that return a Boolean, non-zero is true, 0 is false. But when I'm exiting my program, whether that's with the exit call or with return, then I want to have 0 meaning success and 1 indicate, or non-zero indicating failure. Okay, so we should be good to go. We're actually going to get one error when we compile this because of the C++ stuff. Actually, maybe more than one. So let's see. Let's go back to the command line with Control-Z. I'll bring back that G++ call, and cout was not declared in this scope. Oh yeah. All right, so I needed to include the header file for cout. That won't completely fix the problem, but we'll get a different error message. Well, the same error message at first, but it gives some hints. Suggested alternative, std : cout. Well, everything in the C++ standard library, anything I get from including one of these header files that doesn't have .h on the name, gets put into the namespace std, std. And there are a couple of ways to deal with that then. I could do what you've probably done in most C++ programs you've written, using namespace std. And now, whenever I refer to something with an unqualified name, it will look in the std namespace. This basically imports the entire std namespace into the global namespace. But I can be a bit more surgical or precise than that by qualifying the namespace whenever I use one of these C++ things. So I'm explicitly saying std : cout. If I were using endl, by the way, I would have to use std : endl. Okay, so with that, I think this program should compile now, if I haven't overlooked anything, and it did. Now, I was just compiling it with -c, so I wasn't actually creating an executable. Let's instead create our executable. So -o to specify the output. I get rid of the -c, so I'm not stopping at the compilation step, but I'm proceeding to linking. And that worked. I have my executable. Let me rm this ls-out.txt that I created previously so I can be sure that this is working. I call read here. It tells me success. And I get my files here. So what about all that error handling? How can I test that? Some of the errors are a little bit hard to force. For example, fork failing isn't something that I have very much control over. The only way I could really do that is either set myself a very low limit on the number of processes I can run, which could mess things up if I need to go into Vim to edit something, for example. Or I could fill the system process table up, again, causing problems by overloading my system. So I'm not going to test that one. I could test what happens if the open fails, though. So instead of redirecting to ls-out.txt, what if I redirected to dot? Remember, dot is the current directory, which isn't something I can normally open with the open system call and then write to. I have to use open-dir and read-dir and so on, as we did back in lab 2. So I should get an error from open when I do this, saying that the file is actually a directory. So let's try that. Could not open file for redirection is a directory. That's good. Also, you'll notice I got my failure message here. So let's change this back. Let's see what happens if I give a path name that doesn't exist. There is no directory called nothing in my root directory, so this will not work. No such file or directory. Great. And wait, that's another one that is going to be kind of hard. But actually, there's one more thing I can check. Remember that ls itself, as a program, returns success or failure. It has an exit status, and we did check that. after our call to wait, if it exited and status is 0, we report success. So let's make ls return non-zero by giving it something that doesn't exist. So I'm telling it to ls-l/nothing. Doing that from the command line first, I should get an error message like this from ls. This error message will come to my screen. Why? Well, we have two standard output descriptors, standard out, but also standard error. By convention, a program that's writing an error message will write it to standard error, so that if we redirect the program, that output still goes to the screen. Because I don't want to get my error messages mixed in with the actual output that the program is producing. All right, so ls-l, nothing. So let's make sure that we get that same thing happening within our program. Let's recompile. Run. I got the error message from ls, and then my program reported failure. My program didn't call p-error. None of the system calls that it made failed. Everything succeeded. The only failure was that ls returned an exit status. Exec worked, and wait worked. It's just wait told us that ls had failed, and our program is reporting that as a failure. All right, so that's all for this assignment. You might want to do a little bit more testing if you'd like. And then I'll take my program, my CC file. You should have fit everything into one file. You can take that, upload it to Canvas, and I'll have credit. Now, it's particularly important that you finish this one, hang on to your submission, because the next program, which I hope to have posted in within a couple of days, the next and last major programming assignment for the semester, will involve, among other things, executing external processes and redirecting them. It'll be a little bit more complicated than this. We'll be able to redirect standard input and standard output, and there will be a lot more that goes into it, but this will be a good starting point. So, just to scroll through everything so you can see it one more time, I have my header files. I have a couple of globals, a global constant, and then a declaration for environ. Extern, remember, says I'm not defining a variable here. I'm declaring one that's defined somewhere else. In this case, somewhere else is the C standard library. I have my call redirected function, which, because I'm doing C++, I changed to take const arguments. I'm calling fork, checking the PID, handling error, handling the child process with open and dupe, or open and dupe2, followed by execve, checking for errors in each of those. And in the parent process, I'm calling wait, checking for errors, and then testing the exit status of the process to make sure that that worked. And down in main, I'm defining an array of my arguments, calling my function, and then printing either success or failure, depending on how that went. So that's all for this video. Thanks a lot, and I'll see you in the next videos.